Hello, good morning. I hope everyone is here to talk about taking AI agents into production. Um, my name is Pratik Verma. I'm the CEO and founder of Okahu AI. We help developers take AI agents into production. Today, I'll talk about a specific type of an AI agent, one that makes life easier for people who need to collaborate at work, which is, all of us. So let's see one in action. And since most of our Okahu team is ex-Microsoft, we'll use Microsoft Teams to demonstrate this. So let me kick off screen. So here's a group conversation that I was having yesterday with my co-founder, Prasad, who's the CTO of Okahu, and Lindsay, who's our chief of staff. She's helping out making our marketing events. So we had a technical blurb of Project Monocle, which is kind of shown here. But we needed a short tagline that could be added to a conference email blast. I'm sure a lot of you have done that. So right from the Teams chat, I was able to use our basic agent, in this case, employee Teams basic bot dev, to prep a 15-word marketing copy. It's something that gets quite repetitive. In this case, it was quick. I didn't have to leave our chat to do that. And then everybody was on the same page because they knew what was going on. And then Lindsay was able to get what she needed, which is, pretty crisp this definition of Monocle, which simplifies GenAI app tracing with open source tools, easy instrumentation, and OTel compatibility. So now agents like this can make collaboration very productive. So let's see how a developer would build an like this using Teams AI and Azure. So let's go into our VS Code. So actually, before we do that, let's talk about what agents are. So on the screen here, you'll see, our description of what an agent is. So in its most basic form, an agent is a piece of code that accepts instructions from the user in a natural language, and then it will use LLMs to decide, what task to perform from its available list of tools and kind of instructions. Now, typically a developer historically would have written just code, but with an agentic application, they actually write code along with developer prompts, which add context to the user's instructions to guide the LLM on how to behave. That's what's very different about the way agents are written as opposed to traditional software. So let's see what this looks like in VS Code. So we are going to go into this VS Code thing. It's our IDE where we build different types of agents, etc. And so here's the code of the basic AI agent we saw in that Microsoft Teams chat earlier. Now, in this case, the agent is created using Python and Teams AI SDK. It's something that the Teams team has created for developers that are building Teams agents. And this agent runs as a bot within the Azure web app container on Azure. We found it to be the most easiest way to deploy these bots. And along with that, instead of using OpenAI, most of the company's data we deal with happens to be in Azure itself. So we have found people using Azure OpenAI as a pretty easy, convenient way to deploy their AI agents, specifically for Microsoft Teams. Now, we've also found that when we're using VS Code, having a couple of VS Code extension makes testing on our laptop and then pushing the code to prod much easier than doing without it. So here's a couple examples. So we love the Microsoft 365 agent extension. We love the Azure VS Code extension, the GitHub VS Code extension. And one of my favorites is to help us do instrumentation is the Monocle VS Code extension. It makes instrumenting your code very easy. So now, for a quick overview of this particular, application, when a developer writes a bot, they write the specific, team-specific interaction in the app.py. So this is where they would write, what kind of messages from Teams this bot should receive. Remember, this is the Teams chat interface interacting with the bot on a Azure web app. Now, you would create the logic of the bot in here, giving instructions on what models to use, how should it respond to the models, and what to do in terms of error, and how to add feedback loop to it. So typically, when you're building a Teams agent, this is the code that you would be editing. Now, instead of just writing the logic and code in here, oftentimes people have also added instructions to deal with the LLM to guide how it works. So here's a couple of examples of what a prompt really involves. Notice this is a free-form text. I've just, to be cheeky, added a yo to our greetings in this prompt. And another example of a prompt when you want to be a little bit more focused for prompt engineering, you can take a look at this example where somebody is creating a bot or an agent to help people figure out how to file expenses. So you can get pretty detailed and sort of complicated in a free-floating text. Now, the configurations for how an LLM should treat this particular prompt is also shown in this config, and this determines some of the knobs that are available to you to tune, how responsive your LLM should be, how big or wide the context window should be, all those other kind of things. Now, this particular code happens to be in a public GitHub repo. So later, if you want to try it out yourself, you have the option to do that. If you just go to the GitHub Okahu demos, and it's one of the pinned GitHub repositories. So, so now let's see how we can actually test this functionality. So I'll go back in my VS Code. And in this particular case, I have the code written, pretty easily. And because I'm using the M365 agents, I can make laptop testing very easy. So let's say if I click off the Start M365 agent directly in my application, I will end up seeing the playground for M365 locally running on my browser window. Now here it's mocking up all the functionality that is available to me in a typical Teams experience. I've got some log panels on the right-hand side that allows me to figure out how I'm interacting with the system and what's going on internally. Now, what's really curious about this here is, this makes creating Teams apps very easy, because I can test things with sample user input here, do some interactions, and then go to VS Code directly to change my code, config, prompt, and then see how I'm evolving the agent behavior that I want. So I find this to be super useful. Now, when I'm ready with the basic functionality in here, I can then use the VS Code extension directly here for M365 to push this to provision resources in Azure, which is, instead of running it on my laptop, I can run the application and the bot in the web app, and deploy it to my dev environment or my prod environment. So typically, this is where a lot of user-related going to prod functionality will actually happen. So I would either deploy it into production where everybody in my company can see it in their Teams application, or I would deploy it in an Azure dev environment where I can interact with it more. So now we saw earlier how well the agent worked, in responding and creating marketing copy. But now let's see, what do users and developers typically deal with when they've just started out, when it's not in prod yet. You'll see a type of cases where the agent doesn't work so well and kind of causes frustration. So let's jump into our a different chat. So this is another example of a Teams chat I was having with our team at Okahu, and this is kind of a mock-up of a summary of what we had, so I don't leak any private personal information here. But it turns out so here's an example we saw the other day. So Lindsay tried to use the agent to figure out what day a holiday lands this year. So Diwali, which happens to land in different times at different year, and it's a day off for a lot of us in here. And she asked, when is Diwali this year? And the agent responded with an incorrect date. It was correct for Diwali, but for a different year. Now, this is an example where missing context or not understanding enough context leads to wrong results. So adding the clarification about the year inside the response fixed the point issue, but it made Lindsay wary to trust his agent again and in future. So, which is you should be very careful about these kinds of things as well, because LLM-based agents tend to be very non-deterministic. Now, Let's take another example. This is another type of an example of another bot, a Teams AI basic RAG bot. What this actually has over the other basic bot is it has tools that we've coded in to receive external content. So we've created an action inside of Teams AI that allows us to extract, to get a document from a web URL and extract its content and add it to the context to enrich its response. Now, we found such agents to be quite popular because it's one thing to give a description of a piece of code or text to create marketing copy. It's much easier if I just could point to a document sitting in my SharePoint or a document on the web about what our HR policy is or what our legal compliance needs are. So this type of an agent is quite popular. Now, here's a couple of cases where agents like these don't do it very well. So in this particular example, this agent executed the fetching of the content from the Monaco contributor list, but it didn't actually take on the next step it was supposed to do, which was summarize the content of it. Now, when asked another question from this document, the same one, it failed to fetch it because of a variety of other reasons. So these are kind of some of the cases where you'll run into it, you'll have to deal with, how to handle this. Now, another common case we see is, based on misconfigurations. So you'll see this example where, I try to, instead of summarizing the top feature of Monaco, ask for a little bit more output. So in this particular case, I gave it the same description, but asked the bot to add more thing. And we'll notice that based on the configuration, you'll end up, sometimes abruptly cutting off the response. And this creates a lot of frustration for end users, but oftentimes this is very silent to the developer because the LLM in this particular case behind the agent actually completed the task successfully within the bounds of the instructions given to it. So that you won't actually see a surface of error. And these kinds of errors are really hard to catch, and behaviors are really hard to catch. Now, the net result of this is user gets really frustrated. So you can clearly see that I was frustrated with this agent, and I sort of called it out. And I guess it didn't like that, and it gave me an error. So this leads to poor user interaction. So these are some of the cases that you typically deal with. So what we've seen that from our experience, the AI developers that we talk to who are building such agentic apps for Microsoft Teams, what they're really trying to do is build reliable AI automated experiences to help reduce the tasks, repetitive tasks, get easier answers for the users, and make it in such a way that they're in the collaboration tool of choice anyway, so they don't have to learn a new thing or stay out of flow. And what it really boils down to build reliable AI-enabled automated experiences is to identify what are the typical type of failures in a non-deterministic system, and some of the examples we saw earlier, and then addressing these tasks by either modifying the code, handling and creating new messages. So an example of that would be, I would go in here and add new types of messages, not just the API messages. There's other kind of interactions that I would build based on top of this response. Or in my bot, I will handle a lot of different types of errors. So there's a lot of logic creating here, handling thing that they would, people would have to write. Now, this is what's different about this type of code is, instead of just relying on code here, a lot of the tweaking actually is really happening is this freeform text of the prompt. And that's what makes it so hard to really create reliable AI automated experiences. But it is doable when you know what kind of failures you're running into and how to quickly resolve them. So this is where my company Okahu provides a software tool for developers to do development on their laptop or in production environment. So developers like the one that who would have developed that Teams agent use Okahu to observe how that agent is doing when it's deployed in real life environment outside of the playground. And then when you describe it, because of the evaluation, testing, and other functionality built in, they can then connect that observation to identify what problem is there. Is it a problem with the model? Is it a problem with where the model is running? Is it a problem with user input? And then quickly identify either the pieces of code or places in the code where it needs to be modified, what prompt needs to be changed, or what configuration needs to be changed in order to fix that issue. And then they do it all in real life. So let's see an example of how that actually works. So I am going to go back to my trusty VS Code, and we will notice that, let's go back here in the app.py. So because I have this monocle extension put in, I can just right click on this thing and use Monocle to enable Monocle for Python. Monocle is an instrumentation library that makes instrumenting this code very easy. What it ends up doing is adding Monocle telemetry and assigning the name to this workflow, and then setting it so that all the telemetry from execution of this code gets sent to the Okahu cloud. You have to do a bunch of things in the background about, getting an API key, getting an Okahu account, etc. But once you have those things in place, every interaction that you have that you want to type and want to monitor in either on the laptop or in production can go to a common location. You don't have to worry about it. So let's go see what that looks like on our Okahu portal. So here's an example of a the trace that we saw earlier. So in our chat, we saw the users' interaction and how different users were interacting with the bots in different places. The same interactions, the telemetry from it has been captured and is available in a common place. So from the Okahu portal, a developer is able to see the interaction of the agents as it's running in Azure or in AWS or in GCP with real users. And it's done as accessible as running the same thing on the laptop for test users. So you'll see here in this example, we saw the conversation. There's metadata associated with what kind of message, where in Teams chat is this interaction coming from. And then you can see kind of the trace of the interaction and this final encountered bug that the user, the bot returned back to the user about the error, which is non-informative. You actually can see that it's coming out from a content filtering trigger that is configured on the Azure information side, the Azure OpenAI side. So the interesting part is you can go back and you can see, what system prompt you added and what was the response, how it was cut off here. And you can also see iterations around that system prompt. So you can change that as the tweaks happen. So you can see the behavior of how the prompt, changing the prompt impacts the output of the user's response in real life. Now, when there's a lot of direct conversations and chats going on, you're not going to want to do each prompt and inspection each prompt individually. And then there's lots and lots of things that are going on. So you need some ability to summarize where the problem is, categorize what kind of problems there are, and up-level the issues that come, over and over again. So, so let's see what we can see checkout here. So when I'm inside of Okahu portal, I can, for this particular application, go to the insights directly. And this is where the raw telemetry that we've captured using Monocle, enriched with different tagging and information, is then added and analyzed into create, different pivots. So one of the common things that we end up seeing people do is figuring out where to focus their attention. So in this particular case, I'm showing in the last 7 days, this is an example of a Teams agent, and we're tracking the engagement with it. So a typical thing would be, you'll see that, there's a couple messages we sent out in the playground, but really inside of the real tenant in production, very easily, we've seen a bunch of messages show up. Now, we can break that down and figure out that most of that conversation happened in a group setting as opposed to somebody posting in the Copilot or a given channel. Now, what's interesting here is you can from here figure out in production what and how this sort of agent is doing. And you'll see like there's a couple of users using it, but this is the problematic part. The task completion rate is very, very small. So this is the thing that we do need to fix. So the way we actually do that is we will notice that in this case, the person who created, the developer who created this VS Code application here and instrumentation didn't have to know anything about telemetry, didn't have to know anything about, how to capture telemetry for teams. And they were able to get all of the engagement metrics directly from here. So all the evals and everything else is run behind the scenes for them for a typical thing. So getting started is very easy for people. Now, from here, somebody can actually trace a problem down to, across the components. So you'll notice that in this particular case, it's very easy for us to, because we're operating on the tracing, distributed tracing, and then running pivots on top of it. We've got some other built-in functionality that allow the developer to investigate and fine-tune kind of the source of the issue in the right place. So in this particular example, you'll notice that most of the traffic is happening in the pinging and the message that doesn't actually invoke an LLM. So oftentimes a user will find something that's a problem, and you'll kind of go down to the LLM to figure out what the problem is. But really the problem arises in the handoff between the team's interface and the team's bot before the GenAI code is actually invoked. So in this particular case, we'll see that if you look at the GenAI traces where the message actually involves GenAI, you can do a lot of things like, inspecting the traces and then go drill down. If you've got some errors, you can make your life a lot easier by categorizing them. We, behind the scenes in the platform, have built in, our own agents to categorize problems and find issues, identify bottlenecks. So these are all the functionalities that are available to the developer to actually very quickly identify where in the multi-component part is the issue. Now, what's really interesting is we use our own software to dog food the agents and the LLM interactions that are being used here. So we keep track of, how our prompts are doing with respect to that. Now, typically, once you've figured out the problem is in the GenAI, what you really are trying to do is figure out, where in the inferences is the issue. And so, you can actually drill down directly in here. We've picked out specifically the type of spans that are related to causing going off an LLM making an inference. And these could be for tool selection, these could be summarization, this could be content creation. So all of those types of tasks that involve an LLM are sort of tracked here as an inference. And then we can start drawing, where the problem is. So in this particular case, you'll see like there's a couple errors here, and then we can actually run, if you're interested in performance, we can actually track where you met SLO or not. So you can focus specifically, instead of focus on everything, you can focus specifically on the part of the area that's creating the impact, either in performance or in type of errors. Now, if I were to go into these inferences directly from here, I can then, figure out how to drill down to what actually drives the problem. So, there's a couple of searching and things that we can do in here, but let's imagine that we wanted to look at a broader time window and look at all the things that we have done to change and try out how to improve this spot. So in this particular case, we're seeing all the interactions that were there before, tagged with the appropriate information so that you can kind of make sense of it. So let's see, in this example, what we've seen is here's quite a few bit of models that we've tried, and most of them have been with GPT 4.0. So by tweaking the time window, you can kind of really get a feel for what's going on. And then if you wanted to look at the impact of a particular provider, be it OpenAI directly through API or within Microsoft Azure OpenAI, you can kind of play around with these kinds of things. And you'll be able to then see, okay, how does changing one model or changing where the model runs actually creates an impact on the response of the LLM or the agent back to the user. So these are some of the things that typically a user would run into to solve their problem. Now, let's go back to our example here. So what we've seen so far now that Okahu can figure out how to use the telemetry and monitor lots and lots of agents. So typically what one would do is sit in here, they'll have a variety of their applications that are under various forms of development. They'll be able to tag them with different sort of type of scenarios. And then from one dashboard, you'll see which systems need focus and attention. So in this particular case, this happened so in the last week, there's quite a few bit of errors that were in the Teams employee assistant. And it turns out because those were about handling the incoming messages that we had not written code for. So once we wrote the code for it, all of those cases went away. So these kinds of toolings allow users to create agents on their laptop and then iteratively develop them to make them more and more reliable as they push from lab and laptop to the cloud environment and from cloud environment to prod using real user interaction to help bring reliable agents into production. So to summarize, one thing to take away from this call so far is here are some of the common issues that you should be addressing, and this is based on our experiences that we have working with developers who build these kinds of agents. And basically there's kind of two buckets. The first of the bucket is really about how do you do with handling of additional messages, handling of authorization permissions, source of metadata, context, etc. And then the second part is specifically about how do you do the content filtering or the rate limits. Those are where you'll end up running into problems sooner that are really hard to detect. And then a lot of it really boils down to prompt engineering to be able to prompt engineering or code to handle different types of messages to address the reliability issues. So that's kind of what we wanted to share today. So with that, I'll just basically summarize. What we saw today was, a typical case of an agentic application that companies want to build at work. And it's designed so that the users in the company, people who are collaborating, can instruct, in simple language to automate work that would be quite tedious without leaving the current flow of their conversation and collaboration. And to make that happen, developers need to tweak a variety of different things about how the LLM operates, how the prompting happens, and what code they write to interact specifically with Teams-related messages to build reliable automated experiences. And we also saw how, Okahu is a tool that allows people to very quickly, who are not observability experts and not AI agents expert and not Teams expert, which is hard for any one single person to be an expert in so many of those cases, to really get started up and running and make it easier in one place to get information directly from Teams, which is typically inside of Teams tooling, and Azure and the laptop all together in one place. So you can directly connect the issues that you see in a real life scenario to issues in code, prompts, and config. So I'll close this section out. Now I've added the links to the GitHub repo with a basic Teams agent code, and you can also get yourself a free Okahu cloud account to work with it by going to portal.okahu.co and then following the provisioning procedure. And so just try it out. I've also added my LinkedIn and email if you'd like to reach out, compare notes, or want any suggestions. So I'll take let's see if there are any Q&A at the moment. All right. So let's see. All right. I don't see anything at the moment. If anybody has any questions or suggestions, please feel free to reach out. And thank you for sharing your time. I'll put the LinkedIn message back again so you can, take your time connecting. Thanks. Appreciate it. Thanks.